So today we're going to talk about finding cube roots. So in the last section we talked about square roots, where we had a number multiplied by itself to get to the number we're looking for. So we used the example 25. So 5 times 5 is 25. So that was the square root of 25 was 5. So when we're talking about cube roots, we're looking for a number multiplied by itself, then by itself again, that equals 27. So when we think about what that might be, we have the number 3. 3 times 3 is 9. Times another 3 is 27. So again, we're looking for the cube of something, means itself 3 times. Now, in the last section we talked about 3 and negative 3 for the square roots, but if you think about it, if I do a negative times another negative times another negative, I'm not going to get 27, which is what we're looking for. I'm going to get negative 27. So in this case, the cube roots, because there are 3 of them, you don't have the same situation like we had with the square roots, where there were 2 positives or 2 negatives pairing together to make the positive. So this number is called the cube root. So just like with the square root, we said it was the square root because it was times itself 2 times. This time the cube root is when it's a factor 3 times that number to get to the original. A perfect cube is similar to what we talked about with the perfect squares, because when I take the cube root, I get integers as the cube roots. So, for example, if I do the cube root of 1, I get 1. The next perfect cube is going to be 8, because 2 times 2 times 2 is 8. The next one jumps all the way to 27, so you can notice how the cube roots are going to jump a lot higher and a lot faster. And you're also going to notice that I'm putting this little 3 inside the kind of valley there in the front part of our radical sign. So this symbol right here is called a cube root. So when I see that sign, that is telling me to find the cube root of that number. So finding the cube root of something. So we want to think about a number times itself 2 more times, so 3 of the same factor. Well, if I think of that number, 2 times 2 times 2 gets me the 8, which means the cube root of 8 is 2. Basically, once I have 3 of the same factor, I can take it out. Now notice this next one. The next one, we're looking for a number that times itself 3 times gives me negative 27. Now when we're trying to find the square root of a number, we can never have a negative number, because the 2 negatives make positive and the 2 positives make positive. But notice here, because we have 3 numbers, we actually can do this. And the 3 numbers that I'm looking for that are the same number are negative 3. Because again, negative 3 times negative 3 times negative 3 will give me that negative 27. Now we also used that little quotient property we talked about in the last one, and I can use that same one here. I can find the cube root of both my numerator and my denominator. To help me break this down a little bit, the cube root of 1 is 1. The cube root of 64 is 4 times 4 times 4. So if I was to do 1/4 times 1/4 times 1/4, the 1 times 1 times 1 in the numerator stays 1. The 4 times 4 times 4 in the denominator stays as 64. So the 1/4 is the cube root of 1/64. Evaluating an expression. So again, thinking of PEMDAS here, exponents we said were the same thing as square roots. They're also the same thing as cube roots. So they are still an exponent. So the first thing I want to do is figure out what is the cube root of negative 216. So if I break this down, I need three numbers multiplied together to get negative 216. Well, if I think this out, they have to be negative because I need that negative number there. And if I think of my numbers and I go up, 5 times 5 times 5 is 125. And if I try 6, that will get me that radicand that I need, which is the negative 216, which then means I can take that pair, those 3's out, to then say the cube root of negative 216 is negative 6. Then we can do the multiplication, so the answer is negative 12. The next one, again, this is kind of the big idea. So the cube and cube roots undo each other. They are the inverse operations. So when I see the cube root of 125, the cube root is 5. And then when I do 5 cubed, it's 5 times 5 times 5. I get right back to where I started from. The answer is 125. So next we want to talk about a couple of examples here. We want to just look through a few of these before we move on. So when I do the cube root, just remember I'm looking for some number times itself and then itself again. So 3 of the same number. 1 times 1 times 1, so our answer would be 1. Same thing holds true on the next one. The cube root, some number times itself and then itself again. In this case, 7 times 7 times 7 is 343. The next one's a little bit tricky, but it's just like we did in the last one. So we know our answer is going to be negative, because we know the cube root of a negative will be negative. Then I want to think of the way we did the square roots with the fractions. I want to think about my numerator and then my denominator separately because I think it'll be easier. So the cube root of 27 in my numerator is going to be 3. The cube root of my denominator, which is 1,000, would be 10, because 10 times 10 times 10 is 1,000. So negative 3/10 is the cube root of negative 27 thousandths. On my next one, again, we now have to think order of operations. So the first move that we're going to make is take care of the cube root of 8. Well, 2 times 2 times 2. Then I'm going to move on to the 4 times the 2, which is the 8. Then I can subtract to get 18 minus 8 is 10. And lastly, remember what we said about the cubes and the cube roots. They basically undo each other. So I could certainly go through and say, what's the cube root of negative 64 to get negative 4, and then cube it to get back to negative 64. Or I could just understand that and just get negative 64 right from the beginning. And then all I have to do is add 43 to it. And basically when you have the negative plus a positive, we're subtracting. The negative 64 is bigger, so it's going to hold the negative sign, and we should get negative 21. So here we have a few more examples trying to look at the variable now when we have a given variable. So obviously the very first thing we do, we know to plug in our variables. If x's are 192, my first move is to actually plug them in. And then we want to look at what is next. Well, if I break down and divide these out and try to think about simplifying, I can first do a couple of things. So number one, 192 over 4 becomes 48. So that's a big help. Then I can look at this next number. My radicand under here also divides nice and evenly. So I want to use that. If I do that, I get the cube root of 64. Now we know that that's a perfect cube, so now I can just do the perfect cube, and then I can add those two numbers together to get 52. On the next one, so again, I'm going to plug in when b is negative 3. So 2 times negative 3 minus cube root of 9 times negative 3. So a couple of things. I can certainly do this first multiplication because it's really not going to be connected to the other piece. When I come over here, the first thing I want to do is not the cube root of something. I want to take care of the radicand underneath. And when I do that, I get negative 27. Next, I want to look at the cube root of negative 27, which is negative 3. Notice that I'm doing minus negative 3. And then that becomes negative 6 plus 3, which is negative 3. So next we have a baseball inside of a display case. A couple of things we want to notice. We want to find the surface area. So we got to think about what surface area means. If you remember back from the cube, there are 6 faces. We know that each face, we're finding the area of it, and that we are going to then do side times side, because area of a cube, which are all squares, would just be side times side is the area of that side, and then we would take care of add the 6 faces. But first what we have to notice here is we have a volume that was given to us, which is good to know. We have the volume of a cube, which we know is length times width times height. So we're told that it's 125. Well, basically, if it's a cube, that means that the length and the width and the height are really the same thing. So s cubed. So remember, if I want to undo cube, I take the cube root. So the cube root of 125 tells me that each side is 5. So now I can go into the display case. So the display case, I'm trying to find the surface area. So basically there are 6 faces. Each face is going to be sides squared. Well, we just found that the sides are 5 squared. We know that 5 squared is 25. And then 6 times 5 is going to be 150. Now notice volume is in inches cubed. Area is always in inches squared. So the surface area would be 150 inches cubed.